Hello friends, let us understand the concept of free body diagram in this video. So free body diagram is extremely useful concepts in especially in mechanics in solving the problems where a particular body is a part of very complex mechanical system. For example, if there are a lot of forces are acting upon a body, so in order to derive the equations of motions or to predict the motion of that particular body, we need to understand the free body diagram. So, before going to understand the free body diagram, let us first of all see that what are the common type of forces in the nature or in the mechanical system that you will very frequently see. So, first of all, the very first force is force of gravitation. Second force is normal reaction, which is exerted by a surface on the body. Then the next common force is force of friction. Force of friction acts between two surfaces of different bodies and will always oppose the relative motion between two surfaces. Then there is a force called tension force, which you will find in the strings connected between two points. So this is called tension force. Frequently you will get to see the applied forces. This means the force which is nothing but an applied force by an external agent on the body. So these are the very basic kind of forces that you will get to see while solving mechanics problems. So let us move towards the example to understand what is the free body diagram and how do we derive the equations of motions of a particular body using this concept. So now let us take this example of this person pulling a block on the ground. So let us say this person is pulling this block with a force of F. This force is acting at an angle theta from the horizontal. So this is not a very complex system, rather it is a simple system just to explain you the concept. So here is the block of you say mass m. So in order to prepare a free body diagram of this block, we just have to consider these blocks and we have to eliminate all the things connected to this block or interacting with this block like this string, the ground, everything. You have to ignore all these things. So we have taken this block only and there is a reference horizontal line. So now we'll go through all the forces. We'll consider all the forces that are acting upon this block. First of all, there is a force F which is applied by this person in this direction, theta from the horizontal. Naturally, there is a force of gravity in the downwards direction. So that is the weight of the block that is acting in the downward direction. There is a normal reaction force that is exerted from the ground on the block. So we'll consider that particular force, this direction. This is the normal reaction. And you can see there is a tendency of this block moving in this direction. So let us consider in this particular case that this block is moving towards right with an acceleration of a. So in this case there will be a friction force acting on this block towards left direction from the surface of the ground. So we'll consider the friction force as well. So this is the force of friction acting on the left. So here your free body diagram of this block is ready, but now we have to derive the equations of motion of this block which is moving in the right direction with an acceleration of a. So in order to write down the equations of motion for this block, let us first consider splitting this force F into its components. cos of theta, and there will be a vertical component of this force F sine theta. That this block is definitely not moving in the vertical direction, so that means all the forces acting in the vertical directions are balanced out. So from this logic we can write out the first equation of motion: normal reaction force plus vertical component of force F is balanced by the weight of the block. So this is our first equation of motion, and since the block is moving in right direction, so that means the force, that will be the difference of this component of force F cos theta minus the friction force, that will be equal to mass into acceleration, since it is moving in right direction with an acceleration of a. So this will be our second equation of motion. So this is how a free body diagram has helped you to write down the equation of motion for this particular block.